That's us.
And we're live.
Okay, we're all good.
Good morning, everybody. I'm Lucy Delabriere, and I'm the Project Ignite Coordinator for VitaLearn. And we're here this morning celebrating Hour of Code in Vermont with some of our students, teachers, and our community members from the code community in Vermont. And I'm here with Peter Drescher from the Agency of Education. Hi, Peter.
Hey, Lucy, how are you? This is Peter Drescher, Education Technology Coordinator over here at the Agency of Education. Glad to be here.
And we're also joined today by some engineers from NRG Systems. I'll let them say hi.
Hi, Lucy and everybody. My name is Rob Hale. I'm Principal Software Engineer at NRG Systems here in Heinsberg.
And I'm Andrea Wolga. I'm a Senior Firmware Engineer at NRG as well.
Hi, Andrea. Hi, Rob.
Hello.
And we are here with a group of students from Williston Central School. I'll let them say hi.
Hi, I'm Leah Holy, and I teach design technology for 5th through 8th grade at Williston Central School. And I have a mix of students here. So I have Colin, and Eva, Alyssa, Rory, Tyler, Addie, and Brianna are joining us today.
Good morning.
Morning.
Morning. Morning.
And Peter will facilitate the conversation and our half hour together.
All right, happy to do that. Why don't we start with the students? Tell us a little bit about, we know that you're coding physical objects in your classroom, so why don't you tell us a little bit about what that entails and what you're kind of doing with that? If maybe you can each of you take a turn or something and say something about that, that'd be great.
I'll do a quick intro. So a couple years ago, most of these guys, I think, were able to use Scratch and Makey-Makeys. So that combination was really nice because it was some hands-on work with the coding. And so we wanted to kind of take that up another level. And so I found out about the Microbits, which lend themselves very well to learning coding. There's a curriculum you can actually get online for them as well. So we are using Microbits, and then they have several challenges once they learn different parts of coding that they have to apply and integrate with craft materials to build things that integrates the Microbit. So they each, I think, have some kind of example or something they're going to talk about. So, Glenn, why don't you start? You can just share your project that you have.
Oh, okay. So for my project, I made a duct tape wallet. And so my microbit basically counts, if you press A, it will add $1 to your wallet. If you press B, it adds $5. If you press A and B, it adds $10 to your wallet. And if you were to shake the wallet, it will give you your total. Yeah. I have $15 apparently. And so that's basically it. And
that's great.
All right. Alyssa, is yours working? Or? Okay, why don't you just explain what it does? Maybe you could go a little closer to that.
I was going to say, if you could bring things up closer to the camera, that'd be great. It was a little hard to see the wallet. Maybe we can see the wallet at the end again.
I need a Fitbit, so if you tilt the wallet like this, it counts one step. And you can push button A and B every time you climb a stair. So stairs, and if you tilt it like this, it counts a running step. And if you push button A, it tells how many steps and how many running steps you have. And if you push button B, it tells you how much time you've had the Microbit on.
So on your wrist is the A and B buttons, right? And is there something that runs up your arm, or kind of how does it know about you when you're taking the steps?
Well, I did it so when it tilts, so when your arm does this.
Okay.
Every time you do that, it counts one step.
Do you know what it's called that's in there that helps it count? You guys remember? The accelerometer that's in there, right? There's an accelerometer and a compass that are holding.
Okay, that's great. Thanks.
Rory, you want to share yours?
I made a counting device. So when you press A, it adds 1 point for player A. And then it tells you how much player A has, and it's 1. So, and then when you press B, it adds 1 point for player B. And it also tells you how much points player B has. And then when you shake it, it shows you how much total they have.
That's great. So this is the little video screen, I guess I just saw went by. That just gives you the score of A or B or whatever, right?
Yeah.
Okay. Okay. Yeah. Great. Thanks.
It's in the very bottom corner.
All right, Tyler, you wanna?
Sure. So I worked a little bit with servo motors. I tried to make timing gates like for marble course.
Right there.
And so
Now we can see you. Yes. There we go.
there. So I had it so if you press button A, the servo motor would go down and lower a gate, and then it would start the timer right after that. And then when you press button B, it stops the timer. So like once the marbles cross the line, you press button.
Yep. Now, is that on your screen? Is that like a scratch?
Yeah.
Yeah. Okay. Yep.
That's all the code.
Yep.
What do
Great.
we do the coding in, Tyler? What program is that?
Make code.
Okay.
Yeah.
So it's a free online app that you use.
Yeah.
All right. And could you talk a little bit about the challenges with the motor?
Challenges with the motor. It didn't work too well.
So we had some trouble with the pins, and that was
Yeah.
something we were still
Like the
trying
pins on the microbit and the alligator clips, it didn't send a signal too well.
So we've been kind of problem solving that still.
Yeah.
Huh.
Yeah.
So you were able to problem solve it?
Kind of.
We're getting there.
Yeah.
Getting there? Yeah. Let me just ask a quick general question of the whole group. So how long have you been working on these projects?
You do it for a certain amount of time for each class. It's normally like a week period. Well,
Okay.
each project is a week. Yeah.
All right. This class you're in, though, is a semester class?
It's 6 weeks. 6 weeks, yeah.
Okay.
So I have all the kids as part of a rotation. That's part of their essential arts. So they go to art class, music, and then design class is part of the rotation. So I see them for 6 weeks every day.
Okay.
And we have 40-minute blocks, so it's not a lot of time, but we try to get through as many projects as we can. And a lot of kids will come in during core time or lunch and recess, or come in after the rotation is done to keep going if they're really motivated to try some other things. Abby, you want to talk about yours?
Yeah, let's see the others.
Okay. So mine is a water counter, and when you press button A, it adds 8 ounces. When you press button B, it adds 16 ounces. When you press AB, it shows the total water. And when you shake it, if you don't have 50 ounces or more, it'll say drink more water. So, yeah.
That's good. Do you do sports or something, and that came about from your lifestyle? Yeah, that's great. Making sure you hydrate, right?
Yeah.
All right, Brianna's just working.
Great.
Okay, so why don't you guys head up and we'll tilt the camera a little bit. Who's demonstrating?
Tyler and Addie.
Okay.
What button am
So what's this we're about to see?
Have you ever heard of the game Ghost in the Graveyard?
Think so.
So it's kind of like a score counter for Ghost in the Graveyard, where my 2 demonstrators, Addie and Tyler, they are Team B, and I am Team A. And if I hold this and press A, I get a point, and if they do hold this and press B, they get a point. But they get a point by touching their button without me seeing them. And then if I see one of them move, then I get a point. And it's first to 3 wins. And do you want us to do like a demonstration?
Yeah,
Okay.
I was going to say, yeah, demonstrate.
Oh, you guys had some action here. Okay.
Yeah.
Okay.
Okay, so I count to 3, and then they try and get there. When I say 3, if I see one of them still moving, I get a point. Ready? 1, 2, 3. Oh, I saw you. So I get a point. And then afterwards, if I press A and B, or if I press A, it will show me points for A, and if I press B, it will show me points for B. 3, 2, 1. Oh. Okay, then. Back to corners. Oh. Ready? 3, 2, 1. Oh, I totally saw you.
So maybe you guys want to show the score.
Okay, so now I think I'm player A, so for my score I have 2, and they have 0 because I don't think they actually pressed the button when they did it, so press it. Oh, there you go. Oh, so now they have 4. I guess it was just slow on counting.
All right.
That's cool. Great. Yeah.
Eva's going to just share something a little bit different.
So I've been working with a Ada fruit, which
Circuit
is
playground.
circular.
I'll bring one up.
Yeah. It's circular and it has a speaker and lights. So I've been working with that.
Want me to hold that for
Yeah,
you?
actually, can you bring that up to the camera? That thing you had in your hand there. I wasn't sure what I saw there.
Is that the circuit playground?
It's a circuit playground. So
Okay.
yeah, so some of the kids were working with Microbits, and someone like Eva who caught on really quickly and seemed really excited about it. I said, hey, why don't you try? We just got a grant for a classroom set of 20 circuit playgrounds. So so I have a bunch now. So we're kind of trying to integrate those in with the Microbits. And so some of them are working better for the projects than the Microbits. So the kids are getting a bit of a choice. So Eva really picked up the circuit playgrounds, and she just wanted to show you a code she was working on.
Yeah, I started this code on Monday. When you press button A, it plays "Ode to Joy" and
The speakers are working.
and it changes the lights.
And so the nice thing about Make Code is you can work on your code in the blocks or in JavaScript, and then it has a simulator here so you can see what you're doing before you actually put it onto the device. So she's at that point right now. Yeah. So, and you have a few different songs in
Yeah,
here, so.
I had Jingle Bells also, but my Chromebook broke yesterday, so it's not on my Chromebook any longer.
Can you talk about how you made the song? What you had to do?
I had to program in each individual note and put in all the rests and change the different, like how long you play each note for, which took a really long time. Because "Ode to Joy" is like a fairly long song.
You want to show her?
I'm sure.
So I've used the different notes here.
It goes, no, there's more. I'm not used to this.
Yeah, that's fine to just show them.
Yeah, so it goes down more than that also. And so when you press button B, it plays Hot Cross Buns.
And different lights for that one?
Yeah.
Great.
And then there's one more. When you press buttons A and B, it plays, I don't know what the song's called, but it was in a book.
Camptown Races?
Yeah.
No, you recognize that's good.
And I did
Awesome.
have Jingle Bells, but then it stopped working.
Yeah.
So,
My
yeah,
Chromebook broke.
yeah, she just started working on this a few days
Monday.
ago, really, yeah. So
So
Nice
it
job.
sounds like this works on your Chromebooks and computers, which is awesome since so many of our schools have Chromebooks.
Yeah, I was just going to ask about that. Yeah, that's really great.
and that's
Um,
planning the curriculum.
so,
that's-
so tell me something that I'm sorry, that student, I don't remember that student's name, but so when you had a challenge with that, where do you get help? I don't know. I guess this applies to all of you. Where do you get help when you have a challenge with one of these things that you're working on?
Miss Joey or the tech room.
What about each other?
Oh yeah,
That's-
definitely.
We rely on kids that some of them pick it up pretty quickly or have other coding experience, so it's really helpful.
Basically just fool around with it until I find something that works.
Yeah.
Do you find that a lot of the tools have good tutorials too, that you can kind of, if you get stuck, you can kind of dive deeper into?
Some of the tools have instructions on them, like they'll tell you what the tool does in the corner.
Yeah. So you're able to be resourceful then on that kind of stuff. Yeah, that's great.
I'm wondering if our guests from NRG Systems have any questions for our students before they share their careers.
Yeah, that's great.
Yeah, sure. I was wondering, first of all, everything you guys have shown, that's been so cool to see, and I wish that was around when I was a kid.
Yeah.
All we had was ask your parents about Simon, and that was kind of, now I know how that would work. Have working on these projects helped you understand devices that you use in your day-to-day life better now? And like specifically, which ones do you feel like, oh, I have a sense of how that would work now?
Definitely like the Fitbit that Elena did. Like Alyssa, sorry. My brother has one, so it's kind of cool to see that might be how it works.
Any other things you guys that you think of? Right.
Well, when you use a counting device, it kind of it helps you. I think a good example.
A lot of kids have them like with their scorekeepers, like sports related to their sports.
Yeah, like maybe if you're playing a game of basketball, it might be helpful. Like if you use one for fouls, one for 3-pointers, one for 2-pointers, so it's kind of handy sometimes.
That's a good application. Yeah, that's great.
Now, I think Rob has a good point. I don't think most people realize, you go through your everyday life, and I don't think people realize that processors like what you're using, yours is a very small one, but they're in everything you use. Your car, your toaster, everything in your house, everything you use has processors. Your toaster has processor, I'm sure it does, to light up the timer on your toasters. Your car has probably 50 microprocessors in it. And people don't realize that the stuff you're doing right here is, a small thing, but all of that is in everything you do. So knowing how to do that at a young age is really cool. I didn't learn how to do it, until I was probably 30. I'm 50 now. So I've been doing it for 20, 25 years. But I think it's really cool that you guys are learning that. And you'll, as you walk through your day, you'll go, oh, I bet there's a processor in that cool dimmer switch, or there's processors in everything. I mean, it's really cool. It really runs our world these days. Your iPhone, your everything. I mean, they're everywhere. So it's really cool you guys are getting into this at a young age.
I was interested when I was looking at the blog that you guys maintain in some of the videos, how you were tying it back to some of the kind of fundamental principles. Like, I think the first video that was showing the counters, like I think it was your wallet, for instance, that video, it was in the context of understanding variables and whatnot. And there was another exercise you did that had to do with conditionals, where everybody was reacting to something else and doing a little thing.
Oh yeah.
Yeah.
That was fun to watch, first of all, so thank you for sharing that. What do you think, I'm curious what y'all thought was one of the more challenging concepts to get? Like, what was variables a hard thing to understand, or?
What do you think is most challenging so far?
Maybe to figure out how to program sound in.
Big ones.
Maybe to figure out how to program sound into the machine, because you have to hook up speakers. That didn't always work.
Servo motors. Now, what about Alyssa has been taking it a little further? What's been challenging for you? What were you just working on yesterday with yours?
Doing, I can't go at random.
So she was trying to get a random program in for something, so
Oh, yeah.
the computer to play a game with you, right? So she was trying to set random, and that was kind of a challenge. And I think you solved it, right? Did you get there? Yeah.
Nice. I'm trying to think of other questions to ask. I kind of wish I was there. I could pick up the thing. Why is there a rabbit on the table?
Oh, animals. You guys want to talk about that first assignment that you had? A lot of these guys had this way back in September, so they're trying to remember the assignments probably that they had. Actually, Eva can talk about it. So, can you explain what your assignment was with the pets?
Our assignment, we had partners and they told us what they wanted in their dream pets. And we had to design a pet that would fit their requirements and code a face for it using a microbit.
To show the emotions of.
I see a blinking nose on one of them. It's hard to see them from here, but.
Yeah.
Does somebody want to bring one over to the
The brown dog one actually has a buttons program, but it's a different program. Yeah, you can bring it right up if you want.
Oh, I see. They have microbit faces.
Oh,
very
nice.
cool.
The one Tyler has, you can shake.
Oh, awesome.
Oh yeah, this one. This one goes.
Miles in
This one
front.
has a bunch of different ones. Like, oh yeah, puppies.
Oh.
Angry bunny.
Monty Python bunny.
That's right.
Did you get it working, Tyler?
Oh, I
Great.
smile. Oh, dear.
I think a lot of
That's great.
Those are awesome.
Yeah.
And it looks like you used some design thinking with the empathy stage in there. Leah, do you use design thinking in your classroom?
Oh yeah. So yeah, the first assignment, it was a little tricky for them to have to design for someone else because I think they wanted to design their own pet. So, but it was good to put themselves in the shoes of someone else and try to figure out what their needs were. And then in the end, they kind of debated whether they got to take home their own pet that they got designed for them or made for someone else. But it's been fun. Everybody wants to keep their microbits, so that's kind of a challenge. But they're really pretty reasonable. They're about $20 for the kit. So I think a few kids have actually gotten some of their own.
I have a question. When did you start this program? My two boys went through Williston Central. One's now a junior at CVU and one just graduated. And I don't remember this being there when they were there a few years ago. Did you just start this?
This is my third year in this classroom, but this was, I'd say this program was more, they had Lego robotics and a lot more wood shop. We still have a wood shop here, but it's all kind of integrated and I kind of rotate through the different activities. So.
Okay, is it on all the houses there or just in?
All middle school goes through here.
Oh, okay. Nice. Yeah, I don't remember it being there when my boys were there, but maybe they just, because they're both very, into, one of them out was at Champlain. He's a video game programmer there, so he definitely been into this back then, but I don't recall it being there. It's a very cool program.
So I think this would be a great transition to hear what our guests from NRG do and how our students might be inspired by the type of work that you're doing.
Okay, sure.
I'll go first because I think what I do here is much more like what you guys are doing. I'm a firmware engineer or what some people call an embedded systems programmer. I started out, I went to college to be an electrical engineer and kind of transitioned into firmware. Most firmware people are electrical engineers, and that would help you with your servo motors, for example. When you write firmware, you're writing down at the level of dealing with things like servo motors and switches and actually touching the hardware. You're lighting LEDs, you're running motors, you're inside the car, you're inside your microwave, you're actually running machines. Whereas like Rob writes software. So he's not touching the actual machine. He might be running on a PC or in your iPhone, for example, you know, running apps, things like that.
Those boundaries are blurring a little bit.
They are blurring a little now these days, but you know, when I went to school, they weren't so much. So if you wanted to do stuff like run servo motors, you know, you have an electrical engineering degree, so you actually know how that motor works, and that might help you, you know, when you're trying to run that motor, because you know how it works. So you're writing the code, and you also know how the motor itself works. So it helps you a little when you're trying to get it to run, so you can debug both sides of it. So anyway, what we do here, one of the things, as Rob was talking about, we help wind farmers. And, you know, a wind farmer sounds like a really kind of weird term, but what those people are is they set up these big farms of wind turbines. You know, you see them around with the big towers with the big turbines. And before you can set up one of those turbine farms, you need to go to the bank and say, hey, I need some money to run this, because they're very expensive, millions and millions of dollars they cost. So to do that, you need to basically say, hey, this is a really good spot to put these turbines. It's going to make a lot of money. And so we provide a service to those farmers to say, we're going to take some data from your turbines to say, this is a good spot. So we provide them with towers, which are basically big poles with sensors. These are a lot of our sensors that we have. These are anemometers, wind vanes, things that we put on these long poles that collect wind data. They collect wind speed, they collect wind direction. This one collects humidity.
You guys, I'm sure, studied weather in science class at one point or another, right?
Or you will.
Or you will. So you know about humidity. This is a sensor that detects humidity.
This one, you know, spins around. You can get wind direction.
Wind vane.
Wind vane, anemometer, wind speed. So anyway, these things all sit on this big tower, and what I do here is this is our main product here. It's called a logger, okay? And it basically sits at the base of the tower and collects all the data. All of these have, you know, wires. They hook up to the tower.
So as this guy spins, it's sending an electrical signal to the base of the tower where that data logger sits. And the data logger is taking that signal from that spinning action, or from
and feeding it into here,
or from which direction the wind vane is pointing, or what the sensor readout for the humidity sensor or the thermometer is, and then
feeding it into
feeds it into there. At which point Andrea's code,
just like your servo motor was feeding you a signal and you had to read it and interpret it. So all of that data, there's many sensors on this tower, are fed into this logger. I collect all that data, analyze that data. There's a keypad on here, so I have to read the keys. There's a display, a whole set of menus. There's all sorts of things in here. We have a modem, so it can wirelessly, because this wind farm is out on a hill somewhere, and your little wind farmer is over at his little hut, hundreds of miles away. And so he calls into his modem just like on your cell phone. He basically gets an email, and so his email says, "Oh, here's all my data for the day." That's kind of the concept. So in here, I have to talk to the modem. I have to talk to all the sensors. I have to read all this data. I have to email myself, all this data. So it's a very, it's kind of like what you're doing, but on a much larger scale. And then what Rob does, he's kind of the compatible piece.
Yeah, so I work on the software side. So the data logger and the tower, they're out collecting numbers for maybe a year and a half or 2 years. Throughout that period, any changes like to how that logger is configured, the software that I work on is what connects to that data logger, and then the user can change, instead of an anemometer on this channel, it got swapped out and now it's a temperature sensor or something like that. Additionally, the software that I write can connect out to the data logger, or the data logger can connect to it and deliver that measurement data. So all the, for the last several weeks or whatever, all that measurement data gets collected up and then given to an analyst who's going to say, "Oh, hey, Mr. Banker, we are expecting that this location could produce this amount of wind power, and that would justify the bank loan that the person's trying to get.
Yeah, and Rob's application is a very nice looking, pretty thing on the, the wind farmer's PC that he can set up how often it emails him. He can connect to the logger via this modem that I'm talking to. So it's kind of Rob's talking to me. I'm inside this machine and he's outside the machine, and he can say, I want you to email me 10 times a day instead of once a day, or I don't want you to email me at all this week. I'm going to be on vacation, or whatever it is. And it's a nice user interface, just like, an app on your phone. So that's kind of what we do on the wind side. And, other people in the company do other things with solar power and meteorology and bats and things like that. But that's what we do here.
It's awesome. I know that our students have to leave. I think their bell rings pretty soon, so I thought I'd see if they had questions.
You guys have some questions you want to ask about the wind power? Brianna, go ahead.
When you guys are you the ones that are building the wind towers and kind of assembling the pieces that you put on the top, or are you just collecting the data?
Thank you for asking a question. Okay, first, it's brave to be the first person to ask a question. NRG does build the towers, and they build all these sensors, right? So we have, in our engineering department, we have electrical engineers and mechanical engineers, as well as the firmware and software folks, who are designing everything from the electronics that go into one of these sensors to the housing, the mounting brackets, and everything like that. And then out in the warehouse, we do get the tubing, which is the tower, that mast that goes up, and it's strung out like a giant tent pole. And our tower team, they end up converting that kind of raw tubing into the meteorological tower.
But we personally don't build those towers. We sit at our desks and write code.
Yeah.
Just like you're doing at your desks.
What new innovations are you guys working on with collecting wind data?
The end of the question dropped off a little bit, but you're asking what innovations are we working on?
Like what are the
to collect the wind data?
Are there some new types of technology you're using now or working on using in the future?
Well, there's a couple of things. We're in early stage. Well, first of all, there's some stuff I can talk about, some stuff we can't, right? But let me talk just more broadly in terms of as an industry. What you'll start to hear about a little bit is now something called edge computing. Have you guys talked about that at all? Remember I talked about how, like with the anemometer, when it spins, it's sending an electrical signal down to the logger, and the logger is converting that electrical signal based on how fast the thing is turning. It converts that to know, oh, that means that the wind is blowing at 5 meters per second versus 7 meters per second, right? One of the things that's happening in the industry now is the people are building more and more smarts, more and more computing power into the sensors themselves, right? So this trend we see in the industry, it's called edge computing, because the sensor's kind of in the edge of the technology stack, right? There's nothing else between the wind and the cups here, right? So as the price of computing power goes down and you can actually get a small enough processor, you'll start to see smarter sensors that, instead of reporting down how many microvolts that then have to be converted, it'll actually just send down the wind speed. And so that's kind of an innovation that is starting to get a little bit of steam in the industry. One of the things I mentioned, NRG is trying to do, there's an opportunity for us to help minimize the impact of wind turbines on bats and birds, because sometimes, a bat or a bird flying too close to a wind turbine is going to get hit. And so yeah, I see the faces being made, and
Yeah, we're developing systems to keep them away.
Right. So we're trying to make it so that they avoid coming too near the turbine. So that's something related to the wind industry specifically that NRG is engaged in. So does that answer your question?
Yeah.
Great.
That's great. That's very interesting about the wildlife and stuff. Because yeah, that I know. I used to live out west, and there were huge wind farms in New Mexico, and that was a big concern, was wildlife flying into them or, moving around that. So.
One of the things that, as a wind developer, it's one of the challenges that they have is obviously these wind developers, the community of renewable energy tends to be a community that cares a great deal about the earth and nature and wildlife. And so to be involved in a situation where it's got a negative impact, they don't want to be in that position. So to the degree that we can help minimize that, I think that helps the industry as a whole.
Yeah, sounds great. Sounds great. I'm just time check. I noticed it's almost 10:30. Does class need to leave? Is that we gotta get? Okay.
Thank you so much for sharing your projects with us and for asking
cool.
such great questions. We really appreciate the opportunity to meet with you guys. And if we could leave you with one final thought, just know that we're doing exactly the stuff that you guys are learning about, and we're right here in the community, and still it's right down the road from you. So it's all around you.
There you go. There's your job career right down the road, right, you guys? So keep up the great work. Thank you so much for sharing what you were doing today. So thanks so much.
Bye.
Take care.
Thanks, everybody.
Yeah, thanks Rob and Andrea. That was really great.
Thank you.
Nice to chat with you.
Yeah, glad to meet you. Glad to see you. Really, really great.